let's see now the third step, which is the isothermal compression in the Carnot engine. So till now we have seen that, so there are mainly 4 steps, 2 isothermal and 2 adiabatic. So in the first step, as we know that, so it is the isothermal expansion where the gas is going to expand from V1 to V2. Yeah, so this is how you can write it down. So in this case, even we can write it down the work done. So which we know that, so that is the nRT, again that is your log of, that is E, and again which I can say that, so V2 upon V1. Yeah, so that was nothing but the value for your step 1. Then again that is the work done in the isothermal, your expansion. So similarly we can write it down for the adiabatic expansion over here. Yeah, so when you put it on that insulating base, so for this case also you can write it down the value of your work done. Yeah, so this is NR, again we can write it down, that is a T1 minus T2, again we can write it down as a gamma minus 1. Yeah, so that was nothing but the value of your W2 over here. Now similarly you can write it down again the value of your W3, so which is nothing but nRT, your log to the base E, which is again V3 upon V4 over here. And similarly you can write it down it for your W4 also. So for W4 also, so which is nothing but again that is the same NR, again we can say that obviously the temperature is going to change. Yeah, so the temperature is going to change from that T1 minus T2, again example that gamma minus 1. So if you see that the work done in that W2 and W4, it is nothing but the same. Yeah, and finally the total or the net work done. So the net work done, obviously in the first 2 cases the work has been done by the gas, so that is a W1 plus W2 minus W3 plus W4 over here. So Q1 is nothing but the amount of heat that is gained during that when the gas is going to expand and the gas is released, the heat which is released in case of your this 4th step also we have seen over here. So in that case, so obviously, yeah, so here you can say that, so the heat released to the sink, yeah, so which is nothing but your Q2. So according to that you can also say, for example, so let's say that is nothing but heat releases Q2. So this is your work done, that is how you can calculate. The efficiency is nothing but obviously that is a Q1 minus Q2 upon the amount of heat which you provided it. So that is a 1 minus Q2 upon Q1. That is how we can write it down about the efficiency also. Now similarly what we can do, so I just told you that the value of your W2 and W4 is same. Yeah, so the same work is done in both the process, so that's why it gets cancelled, and this is what we will get the value of your work done. Now further you can simplify this also. Yeah, so efficiency just we talk about it, so which is Q1 minus Q2 upon that is Q1 again, which is 1 minus Q2 upon Q1 over here. Yeah, now similarly we can find the relation between that your temperature and volume also. So basically what we know that, so PV raised to gamma is equals to K, again we write down that PV is equals to nRT, let's say for example. Yeah, again this is constant, so pressure is equals to nRT upon V. So this one again I can write it down just putting the value over here. So this one is T1 V to the power gamma minus 1. So T1 V1 raised to gamma minus 1, T2 V2 again that is a gamma minus 1 over here. Yeah, so this is how we can simplify the things. Okay, again just take the ratio for that particular value over here. Yeah, and you have to just simplify the things for that when it is getting the adiabatic your compression and expansion. Yeah, so this is what we can say for this particular case over here. So this is again just take the ratio and finally you have to just get the efficiency for the same. Now we can just calculate its efficiency with the help of that is the same formula. Further simplifying it, I just said that if you see the graph for the same, so where I'm just going to see the second step. Yeah, so the second step is the adiabatic expansion over here, and again the 4th one is also your adiabatic. One is nothing but expansion and this is nothing but the adiabatic compression. So what we have to do now, again we have to just put the value of that Q2 and Q1. Yeah, so the Q2 is nothing but the heat released and Q1 is nothing but the heat gain. So heat gain, so we know that, so basically for that process, when the heat is gained, that was nothing but your isothermal process. So we can just put the value for that also. So for this particular case, in case of your Q2 and Q1, just put the corresponding values and simplify the things. So finally we will get, which is 1 minus your T2 upon T1 for this case. So the efficiency, you can write it down again in terms of this T2 and T1 also. So this is 1 minus T2 upon T1 for this efficiency. So that is how we can just write it down.